Now I'm going to continue the chapter Electrical Energy and Power, which we started on 23rd July. And we were discussing numerical problems based on electrical energy and power. Now come to this question. In this question, three elements are connected in parallel. Two are resistors and one is cell. All three are connected in parallel. Okay. Now find the total power supplied by the source. This is the source. Okay. And how much power is supplied by this source? Second question is, what is the power dissipated across each resistor? Okay. So there are two resistors in the circuit, and I'm going to calculate the power dissipated or power delivered to these resistors. Okay. And here, this is the energy section, and the first question is, what is the total energy supplied by the source in 10 seconds? Okay. What is the energy supplied by this source in 10 seconds? And second question is, what is the energy dissipated or delivered across each resistor in 10 seconds? Okay. Now come to the first question of the power section. What is the total power delivered? Okay. Now for the source, okay, we have the source, and this source has an EMF of 12 volt. Okay. It means the potential difference is given of the source, and if we calculate the current drawn from the cell, then we can easily calculate the power dissipated or the power delivered by the cell using this formula. Okay, P is equal to V into I. So we can use this formula, P is equal to V into I, here to calculate the power delivered by the source. Okay. And how we can calculate the current drawn from the cell? Okay, this is the current drawn from the cell, and current drawn from the cell is given by the EMF of the cell divided by total equivalent resistance of the cell. Here in the circuit we have two resistors connected in parallel, so their parallel equivalent will be 1 upon Req is equals to 1 by 6 plus 1 by 3, and Req will be equals to 2 ohm. Okay, so when you solve this, okay, for equivalent resistance, then you will get 2 ohm resistor. Okay, do it yourself. So we have total equivalent resistance 2 ohm, and EMF of the source or the cell is 12 volt. Put the values here. So we get 12 divided by 2. Okay, and 6 ampere. So 6 ampere is the current drawn from the cell. Now we use this formula, P is equal to V into Y, to calculate the power supplied by the source. Okay, so P sub S, and this S is representing the power supplied by the source, is given by V into Y. Okay, what is the potential difference across the cell? 12. And what is the current drawn from the cell? Is 6. It is 72 watt. Okay, 72 watt is the power delivered by the source. Okay, now how we can calculate the power dissipated across the resistors? We can use any formula. but for convenience we apply one rule, that is, in parallel circuit the potential difference remain same. Okay, so these three elements, cell, resistors, resistor 1 and resistor 2, are connected in parallel. So the potential difference across each element remains same. Here the potential difference across the cell is 12 volt, and this 12 volt remains same across the remaining two elements. It means the potential difference across 3 ohm resistor is 12 volt. Okay, because 3 ohm resistor is connected in parallel with the cell, and 12 volt potential difference is also applied across 6 ohm resistor. Okay, plus minus 12 volt. Okay, because all three elements are connected in parallel, so in parallel circuit potential difference remain same. Okay, now for each element we know the resistance, we know the potential difference. So which formula is suitable for power calculation? The last one, V square by R, because we know the potential difference V and we know the resistance R. Okay, for each resistor, for each element, so we use this last formula to calculate the power delivered. Okay, the power delivered across R1, say this is R1, okay, and this is R2. Okay, so the power delivered across R1 is equals to V square upon R1. What is the potential difference across R1? 12 volt. So 12 into 12. V squared means 12 into 12 upon R1. R1 is 6. 6 to the 12, 24 watt. Okay. Now calculate the power delivered across R2. Same formula, V square by R2. It comes out to be, it is 12 into 12, because potential difference remains same, divided by resistance is 3. 3 for the 12 means 48 watt. Okay. Here we have two parts. This is the power supplied by the source, and these are the powers delivered across each element. And according to energy conservation, the total power supplied must be equal to the total power dissipated. Okay, now add these two, 48 plus 24, it is 72 watt. Okay, so this is the power dissipated and this is the power delivered or supplied. And you see that the total power supplied is equal to the total power dissipated. Okay, so this is the power calculation. Okay, now come to the energy calculation. We have this energy calculation formula, that electrical energy is equal to the power multiplied by the time. Okay, first question is, what is the total energy supplied? The total energy supplied is equals to the total power supplied multiplied by time. What is the total power supplied? This is the total power supplied, 72 watt. So 72 watt is the total power supplied, and I am going to calculate the energy for 10 seconds. So energy supplied for 10 seconds is equals to 720 joule. Okay, 720 joule energy is supplied. Now what is the total energy dissipated across R1 is equal to the power dissipated across R1 multiplied by the time, and this is equals to the power dissipated across R1 is 24 watt, 24 multiplied by time is 10 seconds. Okay, this is 240 joule, and the energy dissipated across R2 is equal to the power dissipated across R2 multiplied by the time, comes out to be 48. Okay, the power dissipated across R2 is 48 multiplied by the time, that is 10 seconds, is 480 joule. Okay, now when you add the total, when you add the energy dissipated, okay, across the elements, then it is 720 joule. This is energy dissipated and this is the energy supplied, and you see that both are equal. This is due to the energy conservation. No energy is stored. Okay, the total energy supplied by the source is the total energy dissipated across the elements. Okay, so note it down.